Let's look at special right triangles, 45, 45, 90. Here I have a rough sketch of one, and this is my 90-degree angle, and it's opposite the hypotenuse, just a reminder. That's supposed to be an arrow. Now, the 45-degree angles are up here and here, and they're equal to one another, but that's significant because that means this side is equal to this side. So I'm going to put a tick mark there and there. And that might not always appear on your sketches. It's something you're supposed to know. If the angles match, the sides match. All right. The relationship on the sides of this triangle, 45, 45, 90, is thus. Whatever this length is, let's say we don't know, whatever it is, this one is the same. And furthermore, this one is clearly it's longer. Well, it turns out it's exactly radical 2 times longer. So whatever this is, you multiply it by radical 2, and that is the length of the hypotenuse for this kind of special right triangle. Here's what it looks like with numbers. All right, it's obviously not drawn to scale, but because these angles are 45 degrees, we have to admit or assume or accept that these sides are equal to each other, okay? Now, suppose this side is 1. That means you know this side is also 1. And then to figure out the hypotenuse, you're simply going to multiply this side times radical 2. Well, 1 times radical 2 is radical 2. It's the same thing. You don't even need to write the 1. Let's look at one with some more interesting numbers. Suppose I told you this side was 5. Then this side is 5, and the hypotenuse here, that is 5 times radical 2, which is 5 radical 2. And finally, suppose I have one where you're given the hypotenuse rather than one of the legs. For example, 10. If the relationship to go from the leg right here to the hypotenuse is to multiply by radical 2, then to go to a shorter side, in other words, in this direction, you would divide by radical 2 because you're getting shorter. So we're going to take 10 and divide by radical 2. And that would be the length of this leg here, 10 divided by radical 2, and so is this one. Now, as I mentioned in an earlier video, this, although is mathematically correct, we don't like to leave a radical in the denominator. So I am going to simplify that over here. Let me make space. This is our scratch work. So I've got this leg that is 10 divided by radical 2. Mathematically, it's accurate, but it's considered unsimplified. So I'm going to rationalize the denominator, and the method is to multiply by that denominator. Radical 2 over radical 2. And so this will simplify it. Here's what it looks like. Multiplying straight across, 10 times radical 2 is 10 radical 2. And radical 2 times radical 2 is radical 4, but we know the square root of 4 is 2. And look at this, 10 over 2 is reducible. 10 divided by 2 is 5. So I can rewrite these as 5 radical 2. And that is a special right triangle, 45, 45, 90.